really like this video because when you watch this, what you see is effectively the dream many of us have had for many, many years, which is a robot in the home doing many of the chores we wish robots would be doing for us. But of course, there is a catch. And the catch is that this robot is being teleoperated by one of the students who built the robot. And so every single motion is really puppeteered by the student. But what it shows is that the hardware is capable. What we really need is better software, the AI, to make this robot smart enough to do these things on its own.
The most interesting breakthroughs in robotics are in the software and artificial intelligence domains. This video is targeted towards aspiring self-taught robotic software engineers, and in this video I'll be giving you a list of 64 open source robots that you can use to learn robotic software tools and build a software skill set. So let's get started. Before we proceed, let's address the elephant in the room. Do you really need hardware experience as a robotic software engineer? Well, one thing is clear that you do not need to learn how to build mechanical components or mechanical systems as a robotic software engineer, or even program printed circuit boards or build electronic components from scratch as a robotic software engineer. But how much of robotics hardware experience do you need if you're working with softwares, and do you really need it? So the best way to answer this question is to look at the job descriptions of robotic software engineering profiles and really look at the requirements section. Do they require you to have hardware experience? And this is exactly what I did in order to really help you accurately answer this question. So I looked at a lot of job descriptions of robotic software engineering positions, and I noticed that most of them state that they require hands-on experience with autonomous systems, or they require experience both with robotics hardware and software, or they require experience, hands-on experience with real world autonomous systems, hands-on experience with robot control, 3D graphics or other systems, or statements like that. So these are in a lot of job profiles, although not every robotic software engineering job profile, but this is but on enough job profiles for us to really come to the conclusion that you do need a certain level of hardware experience. And of course, as a robotic software engineer, you would be programming hardware, you would be programming robotics, you would be working with sensors, cameras, and hardware components. So this makes sense to have some hardware experience. So what should you do now? Should you should you buy a robotics kit in order to gain that hardware experience? Because as a beginner, you probably do not have that exposure um, by working in a company. So what should you do? I would say that even though the companies require that experience, you shouldn't really invest in a hardware kit, at least at the beginning. You don't have to invest in a hardware component for several reasons. One of the reasons is that robotic systems can be expensive, and second is that you can gain relevant experience even without that. When should you invest in a robotics kit? After you have developed a certain level of robotics software skills, and you can do that by working in simulation. After you are absolutely sure that, hey, I want to work in robotic software engineering and I have the basic skills, then it is the time that you can consider investing in a robotics hardware kit or an open source robot. You can develop robotics software skills by watching my video titled Robotics Software Engineer Roadmap for 2024. This is a step-by-step guide where I have given you 19 specific steps with links to relevant resources that you can just follow and become a self-taught robotic software engineer. Okay, so you have cultivated some basic robotic software skills by working in simulation environments. Now you want to gain some practical experience working with some hardware components, and you can do that by applying for internship or part-time roles, and in some cases even applying full-time roles directly. So once you do that, you would have exposure to robots at the companies, and this would allow you to have that experience working with real-world autonomous systems. And once you do that, you can of course then consider investing in a robotics kit, although this is an optional step. You do not still need to do that. Another point that I would like to mention is when you're choosing a robotics kit, do not invest in cheap Arduino kits that are designed for hobbyists. The experience that you gain may or may not be very relevant for most professional robotic software engineer positions. So make sure to invest in a good kit that has robotic systems similar to the kind of products that are being developed by the industry. So there are certain things that you should look for when choosing a robotics kit. And I would say the number one thing is that it should be compatible with ROS, it should be compatible with Python and C++, because these are the standard libraries used for robotics. Uh, the hardware kits should be similar to the kind of products that are used by companies. It should have great community support. It should have a really good software ecosystem. The cost and budget for the robotics kit should be within your reach, should be affordable to you. Have a look at the reviews and warranty, because if you break some components and if it is a cheap robotics kit, you would need to consider those things before you purchase. Does it have enough warranty? Can you really repair some things and things of that nature? Is the product robust enough? It should of course be open source, and there should be great documentation. The documentation is very important, because if you choose to buy a robotics kit with poor documentation, you might struggle with it. And your goal is to become a robotic software engineer, and that means you should spend a vast majority of time cultivating robotics software skills, working on programming, working on software frameworks, and not a lot of time really focused on hardware components that you may or may not care about. Okay, so let's talk about wheeled mobile robots first. So the number one robot, and you've probably heard about it many times, is that called Turtlebot. There's a lot of resources on ROS Wiki available with regards to operating the Turtlebot. A lot of tutorials, a lot of uh, YouTube playlists, and things of that nature. So Turtlebot is probably the most commonly used open source robot for educational and research and teaching purposes. So it has a certain versions. So Turtlebot 2 no longer operates, it is discontinued, and there's Turtlebot 3 and 4 that you can still buy. Turtlebot 3 is slightly cheaper than Turtlebot 4, and this is something that you can consider based on your budget. So let's have a look at the GitHub repository for this. If we look at the GitHub repository of Turtlebot 3, we see that it is really very well documented. There's an e-manual uh, for Turtlebot 3 by Robotics, and it is upgraded with Raspberry Pi 4. So this is a pretty updated and well maintained robot, and there are significant progresses in all of the packages. So Turtlebot 3 bring up, description, navigation, slam, teleops, and all of these things are kind of systems or packages and frameworks that you would expect to work in the industry as well. So in order to buy this robot. You can buy it on the robotis.us website, or you can look at other distributors, and you would be able to see that turtlebot 3 waffle is around $1,700, while turtlebot 3 burger is about $660. So depending on your budget, you can choose any of these. So I would say the general range of robots is uh, around 200, $300 to, it can go to 19,000, $20,000, $50,000, depending on that. Um, but our robots are for educational purposes, so you could expect something to in this range from 200, 300, or even $150. It's also possible, uh, to around 2,000, $3,000. So expect robots in these range. Okay. Number two is NASA JPL open source rover, and this wonderful design, which is similar to the kind of rovers that are designed for space missions. It is an open source project, and you can find the GitHub repository here. It is very actively being updated. In fact, last commit was 2 weeks ago, and all of the documentation is available here. And the cost is around $1,600, which we saw that's about the cost of a turtlebot 3 waffle. So this is something that you can absolutely consider, and there is also a list of parts and bill of materials that allow you to really buy individual components and assemble it. Another small rover is the Soppy the rover, and this is also open source with all of its components available on hackaday.com. It has its components defined here. It has other files and documentations available, and the GitHub repository is also available. It's open source, and it is also quite actively developed. The last commit was 4 months ago, although not as active as the other project that we just saw. So this is something that you can obviously also consider. I think this project and the previous project are more if you want to explore more the mechanical side of robotics along with the software. So I don't think they have compatibility with ROS, this particular robot, but this is a nice exposure for you if you're interested in space robotics, and then you can expand and build your own software frameworks. You can even build your own ROS packages for this if they do not exist. So the next one is this small robot called Donkey Car, and this is also open source, and we see on the GitHub repository that it is also being actively developed, and the build instructions and software documentation is very well. There is a Discord community is something that we place importance on when selecting a robot, and it is something that you can program in Python. So these are all really good points. I'm not sure if you can use it with ROS. Probably not. You cannot use it with ROS, I think. Uh, so that is something to consider. But apart from that, I think it has really good instructions on assembling it, and it is pretty simple to build because it is a small size robot, and it probably does not require a lot of additional tools for assembly. Some basic electronics and mechanical tools would be sufficient. So another larger rover is called Mars rover. This is also an open source GitHub repository that if we open it, we will be able to see that it is not as actively developed. So these rovers are things that I would like to recommend you if you want to gain some hardware exposure, and if you want to see, hey, do I want to also explore the mechanical side of robotics? So this is something you can explore. The CAD models are easily available. It's programmed in C++, and that is something that's good. The list of hardware is available, and we can really easily assemble it and build it from scratch, although this might require a lot of tools to really make that assembly, but it should still not be as complicated.
Readily available hobby hardware. The total cost of building such a robot is only $50. We release our design for free to the community. The
Now, if the robots that we have seen so far really discourage you because they're too expensive and you cannot afford it, this is a robot that is really good because it is way cheaper than most of the open source robots that I have shared so far and that I would be sharing. So, this is called OpenBot, and this is relatively easy to build. You do not need any additional complex tools, just some basic tools to really assemble it. And there's this GitHub repository that is available that is also very actively maintained, and you can use your smartphones and turn it into robots. So it's pretty cool, and the instructions are also very good. It has a website, openrobot.org, and there's a paper on it. You can read instructions on what it is intended towards. There's this GitHub repository that we just saw. You can actually buy it on Amazon itself for $500, but you can also assemble it from scratch. So, absolutely good robot to give you that exposure to autonomous robots. And there's also Discord, there's also Slack channel to connect with the OpenBot community.
using a remote control. Here you can see my dad controlling the robot using a standard Xbox gamepad.
So OpenMower is also another interesting robot because it is very similar to the kind of robots that you would expect to work in the industry, and it's an autonomous mobile lawn mower. And this is something that you can also use it, so it has practical utility. If you're looking for a lawnmower, you can actually build it or buy it and really program it from scratch and really gain that experience to building mobile robots. And it is compatible with ROS, which is a huge advantage because ROS is something you have to learn. It's being actively maintained, another positive. And as far as the documentation is concerned, I think the documentation is also pretty good. So installation instructions for ROS Noetic. So ROS Noetic is also one of the more recent ROS packages. So this looks good. What I'm now looking for is the documentation for this. So if we go to openmore.de, we see that there's really good documentation here on how to assemble it, getting started with it, robot assembly, software components, all these kinds of things. So if I look at docking station assembly, so there's details to it with pictures, and this is what I like about this documentation. There's a really good Discord community and GitHub community. Another positive, so overall I see mostly positives on this, and it is open source. You can support and contribute. You can do a pull request on this GitHub repository. So if you work on it and if you say, hey, this thing can be improved, you directly contribute to open source, to this open source project. And contributing to open source projects is one of the best way to not just learn but also improve your employability, because the companies see your GitHub and they see, hey, he has contributed to this really nice open source project. So this is something that you should definitely consider, contributing to open source robotics projects.
Built from the blueprint of a Roomba robot vacuum, meet the Create 3 educational robot. iRobot's new mobile robot development platform for learning ROS.
So it's iRobot's platform that is specifically designed for you to learn ROS. So it is designed from the same framework as the Roomba vacuum cleaner. So makes it really close to a real world robotic product, and that is why this is one of the best open source robot products that you can work with. It also has its GitHub repositories available. It is compatible with ROS 2 even, and there's clear set of instructions available, and the documentation is basically perfect. You can buy it for 529 euros. So it is a very good option if you're considering between Turtlebot and this is also a really good option to consider. Now, this particular robot by Hello Robot called Stretch is not just a mobile robot but a mobile manipulator. So, it is a mobile robot with an interesting stretchable and extendable manipulator system that you can use for grasping object as well. Although I would say this is more on the expensive side of robots. So, it is pretty expensive. In fact, it's $19,950 plus shipping and taxes. So it is very expensive. I think this is a robot that you can consider if you're looking to build a startup, or if you're looking for practical utility, or if you're just super rich, you can consider buying this. And if you go to the GitHub repository, it's very actively maintained. It's compatible with ROS. You can use it with Python. So these are all positives. The only downside is that it is really expensive. Okay, so this is another interesting robot called Kaya Robot, and it can move in all directions. And if we look at the buying or building instructions, it is first of all by Nvidia, which is a huge advantage, and it uses a real sense depth camera to see the world around in 3D. It's built on um, Jetson Nano, which is Nvidia's board, and it has an onboard IMU and position feedback. So these are details that you can look at. It has Nvidia Jetson Nano developer um, kit that you can also consider buying here, and all of the details and components are mentioned here. So this is, I would say, relatively affordable robotics kit, because this is specifically designed for educators and learners who want to really play with this robot and learn and develop their robotic skills. So Kaya Robot, this is the GitHub repository. You can have a look at NVIDIA Isaac SDK documentation, which is what it uses. The only disadvantage that I find with this robot is that it is 4 years old and it is not being actively maintained. So this is a disadvantage, obviously. And all the instructions are there, everything is there, the documentation is fine, there's images and everything. But it's just pretty old. You can still consider it, and you can even expand on and contribute to this open source project and build your own repository even. Another cool robot is called Lino Robot, and this is also compatible with ROS. And this is something you can definitely use to learn ROS, develop programming skills, Python skills, and so on. Again, this is also not as actively maintained, but there's good documentation. There's tutorials for getting started, supporting IMU, Linux operating system based. It mentions the tested boards installation, ROS installation. The only disadvantage is that it uses older versions of ROS because it is not as actively maintained now. But this is obviously also something you can consider. It uses you can create a map, you can perform autonomous navigation, and all of the basic mobile robots and autonomous driving vehicle things and algorithms that one might implement. And you can probably contribute to it and make it progress further if you really have that motivation. uh, Overall, it's a good product, but just not that actively maintained. So this is a robot that is called ROSbot 2R, and is specifically designed for you to learn ROS. So there couldn't be any better robots. I mean, there are comparably good robots, but this is one of the best robots for you if you want to learn ROS. It is in Turtlebot and I Create, the robots that I talked about. They're also very good. This is also a very good robot, but this is more on the expensive side of robots. It's actively maintained. It supports ROS. There's ROS packages. You can work with Gazebo, navigation, mapping, sensors. All of these packages are there. And if you consider buying it, it's around $2,500. So this is uh, one disadvantage, but if you have the money, you can consider buying it, obviously.
Basic examples from just controlling from your web browser in Python. It's super easy to do. To more complicated examples like using AI for avoiding collisions. And then we go all the
So we saw some of Nvidia's robots that were not that actively maintained, that are not being that actively maintained, and this one is uh, another Nvidia robot called JetBot, which is another mini robot uh, that uses Jetson Nano. And I would say this one is something that you can absolutely consider. This has last commits in the previous year, and there is really good documentation that is available. So you can really buy this as well. You can buy assembly kits. You can buy it from the distributors and everything, and it is affordable. This is the huge advantage for this robot, is that you can build it or buy it for around $150, and it is designed for educational purposes. There are tutorials from basic motion to AI based collision avoidance, and it is fun, interactively programmable from your web browser. So this is an AI robot that is specifically designed for you to learn AI and make it more autonomous. So, absolutely something you can consider because it is more affordable as compared to most of the robots that we've seen so far. So, another robot is called Magni Robot, and this is a pretty bulky robot, and it is a larger sized robot, and you can see that it is slightly more actively maintained. It is also compatible with ROS. It has all these launch files and all the drivers, and all the packages are available. So this documentation wise, it also looks good. And if you choose to buy it, it is powered by ROS software, can handle vision, localization, communication, and mobility. You can really learn the state of the art in robotics by using this robot. You can perform navigation. Only thing is, again, it's $2,500. So this is a robot called Open Podcar. This is an open source autonomous uh, vehicle that you can really built from scratch. There's a bill of materials available, software setup, hardware setup. So there's a really nice table of contents, and there it's a really long documentation that you can refer to. Everything is there with pictures and details. So this is an interesting project for you. You can build the hardware and you can also do programming. So it's Python based. It uses ROS Kinetic and Gazebo 7, which are already installed directly. If you can, try to use newer versions of ROS, but if not, you can also work with the older versions and really gain that exposure. So going to the build instructions, here are the bill of materials and everything. This bulky huge box type robot is called Morph, and this is another open source project that is also not as actively maintained, but it is based in ROS. There's ROS packages available for this, but older versions, as it is not currently uh, that actively being developed. And there's a Hackaday page for it. It's called Modular Open Robotics Platform for Hackers, Morph. And all the details are there, all the parts list and component lists are there. So this is something that you can definitely build upon. I would say you can take inspiration about hardware if you choose to build this robot for yourself. For this case, the software is a bit outdated, but you can choose to also upgrade it, and that can be an open source contribution, or you can uh, just take an alternative software setup, or electronics could be different. So this affordable multi-agent robot is called Musher, and it has stereo camera equipped with it. And if you look at the build instructions, it's very well documented. There's a proper table of contents. They also mention prerequisites. There's a bill of material that you can just download as a PDF, and there's a list to vendors where you can buy. All the individual components have been mentioned here. 3D printing process has been mentioned. What are the steps that you have to do? Everything is depicted not just visually by images, but there's also videos explaining certain things. So it's a pretty long documentation. Obviously, something that you can definitely consider. So this basketball following robot that we just saw is called Scuttle. It is relatively broad. It is not that high in terms of its height. It's less, but it is a pretty flat robot, I would say. And in order to buy it, you can just go on the website scuttlerobot.com.org and shop, and you see that it's can be bought for $539, around $600, and around that range. And you can even buy kits or individual components separately. And this project is being developed. The last commit was 9 months ago, and it is open source, maker friendly. It has a payload capacity of 40 kg, so you can use it for some of your personal utility for transporting and stuff like that. It is low cost as compared to a lot of other robots. And so this is another robot that you can take for hardware inspiration. You can look at the community. There's also uh, a good community. There's resources on how to deal with it. There's mini guides and proper documentation for each. Just bill of materials is there. And if I look at it, then there's this parts list here, and you can see all the individual chassis, electronics, wheel assembly components, scuttle, mini, all of these details are there. So community is good, documentation is good, could have been more actively updated, but this is absolutely something that should be on your list if you are choosing to buy robots. This is another cool small robot called Jet Racer, again developed by Nvidia. And if we go to the GitHub repository directly, we see that it's also 2 to 4 years old, so not as actively maintained. I like the overall mechanical and electronics design. It can be used for robotics races, and you can probably use it for some um, competitions, or take inspiration and build a robot like this and participate in some robotics races. That would be interesting because it's based on Nvidia Jetson Nano, and it can be used to drive really faster for races. It's an autonomous AI race car. So parts list is available. There's other Jetson Nano based robots and repositories that you can look into as well. So the software setup has also been documented very well. There's some examples on how to perform basic motion on that robot and more details. There's a Jupyter notebook that performs for road following, or to use it for road following and stuff like that. So overall, documentation wise is good. I don't know if you can use it with ROS. So that is one thing that you need to look into. Maybe there's other modules related to it that you can use with ROS. But at least on this repository, I don't see any utility with ROS. But again, have a look at uh, the documentation. There's this nice notebook that is available as well that you can run and play with. Number 20. So far we have seen 19 robots. What is number 20 now?
The fact that it's only $10 means that we can make these robots cheap enough that girls can take them home and be able to program them themselves. And then this is all powered by.
So this is probably one of the cheapest robots. It's also relatively small and easy to build. It uses Python and Turtle program to really draw several shapes, program these shapes, program the robot to draw these shapes. So it's very interesting, although it is not, you cannot do many advanced things with it. So it is still fun if you want to build some interesting things and you want to gain an initial exposure to robots. The main advantage is that it is really low cost and you can really build it under $40. The bill of materials is available here. You can also really buy a kit as well, and that would be around $95. You can build it for yourself, and that would be even more cheaper, as I mentioned. So this robot is called Bobblebot, and this project has been documented on hackaday.io, and the documentation is also pretty robust. It's pretty elaborate and comprehensive. All the details are there. There's even video tutorials, gazebo simulations, all these kinds of things are there. And if we have a look at the future work, they also plan to use it in ROS. And there are also GitHub repositories for these for the Bobble controllers that are available. You can really uh, use it in simulation and work with ROS and use it on Windows, all these kinds of things. And this is a really good robot. You can have a remote control and control it using that. So seeing this robot, you might be wondering, hey, you've already shared Turtlebot. That was the number one project that you shared, right? Well, wrong. This is Tortoise Bot. This is a robot that is very similar to Bot, and it is developed by Rig Beetle Labs. It is available at a slightly lower cost than the Turtlebot. Turtlebot is actually pretty expensive, but this bot is relatively cheaper, and it has almost all the features that you have with Turtlebot. So if we look at the Tortoise Bot GitHub repository, it's also very actively maintained by Rig Beetle Labs, and the installation process, all the documentation, demos, everything is very well documented. If I go to getting started, they have details about Tortoise Bot, its key features. You can perform sensor fusion, it's ROS based, it's open source. All these kinds of things are really well documented, and there's details on hardware assembly as well. So absolutely something you can consider. The images are still loading, so their documentation is also comprehensive with image based, with all of the components and how you can assemble it. It's also relatively easy to do. So if you are in India, I would say this is a really good option to consider, because it's also cheaper as compared to most of the robots. You can afford it, and you can do ROS. It is now also compatible with newer versions of ROS, I think, and you can. There's good community. Rig Beetle Labs, I think they also offer mentorship for ROS programs, so you can also directly learn from them. So this is a really good robot that you can consider.
For them. What we were really trying to figure out though was how we can create an educational content around it, and that we can apply it hands-on using a vehicle. So a vehicle was the essential core.
So this is a robot called Deep Racer, or an autonomous vehicle developed by Amazon Web Services. It's called AWS Deep Racer, and you can really directly buy it on Amazon, and it costs around $400. And if you look at the GitHub repository, it's not as actively maintained. The last commit was, let's say, last year. But it is a relatively good package because it's compatible with ROS, and it uses ROS navigation stack. It has really good documentation as well. It's All of these things are available for free. Dependencies, information on dependencies, and all these things. Now, if you were overwhelmed with the previous rover based robots that I shared, and that they were too big, and they might be more expensive and more difficult to manufacture and make, and you want to clearly just start practicing and learning the software side of things, then this robot called ExoMai is actually something that you should consider, especially if you are interested in rovers. So so if I click on the GitHub repository now, you see that it has a good wiki. The documentation is good. I think documentation is probably good for most of these except some. There is a good community. There's a Discord server that you can join, and there is an official website that we can look into. And if I click on start building, then it again directs me to the same building instructions. There's this 3D model available, compatible with ROS. It's 250 euros to 500 euros, so also relatively cheaper comparing to other robots. And specifications are available, and there you can even contact the owners of the repository, and there's a Discord community there. So all of these things are positives. Okay, so far we have talked about mobile robots, but you have probably seen Boston Dynamics legged robot called Spot. and it performs these complicated parkour and jumping movements that are really fascinating to watch. What if I told you that you can actually program these legged robots for yourself? You can even build these robots and learn a legged locomotion from scratch all by yourself. And now I'll be sharing with you a list of quadrupeds, open source quadrupeds.
Mini Pupper can perform self-driving capabilities like SLAM, navigation, object tracking, and pet detection features for providing a live connection with your pet.
So this robot is called Mini Pupper. It is yellow, and the design looks quite similar to Spot, Boston Dynamics Spot, and it is actually absolutely open source. And if I look at the GitHub repository, we see that it is well maintained. It's based on Raspberry Pi. There's a Kickstarter page where there's more details on the documentation of it. There is proper documentation available also on minipupperdocs.read read the docs.io, and it is a pretty lengthy documentation, quick start guide, run Pupper robot. How do you run that? There's videos demonstrating it, there's images demonstrating it, and then if you go next, there's also detailed videos on how to assemble it. So it's very well documented. This is the CAD model for this. And let's have a look at the Kickstarter page. So there's more details on the Kickstarter page on calibration and ground interaction, integrating AI and object detection with it. So a lot of interesting stuff, and all of these things are open source. So which is what I find really fascinating. There's a Discord and Facebook community as well. So it's really possible for you to work on these legged robots. So another legged robot, open source legged robot, is called Quadruped by Servo, and this is something that I would recommend if you want to just have inspiration for mechanical design of it, because this is more suitable for that, I think. And there's videos on balancing and walking which are fun to watch. You can go ahead and watch that. There's details on the hardware. uh, all the components are also available. There's details on how to assemble it. So this one would be more interesting from mechanical standpoint. There's also details on um, electronics and battery and simulation. Simulated simplified model is available in vrep. So this is a simulation platform that they've used for this. So this small Boston Dynamics inspired robot is called Spot Micro AI, and this might not be as robust as the actual Spot. In fact, it is pretty shaky um, and not exactly something that you can use for practical purposes, but this is something that you can really work with to learn robotics, and it is very interesting to even build and program this. So Spot Micro Quadruped project, this is the GitHub repository. This is the RWIS simulation that we see moving each of the joints. So there's 12 servo motors there. There's some general instructions on how to launch and run it. Description of ROS nodes is there, and then there's also a GitLab community, which I find interesting. So all of the details are there about electronics and simulation separately. Yeah, just go ahead and explore this robot, and this would be a very interesting project to build. So if I go on getting started now, in the documentation, you see all the hardware and electronics are available, and you can really build it. So another interesting open source legged robot is called Good Boy, and unfortunately I think there is no proper GitHub repository for this, and there is no videos available anymore. The videos are made private by the author, and but there's good 3D printing instructions, build instructions, nice designs that they consider. It's based on Arduino Uno and uses Adafruit Power Boost. All the details about the software and hardware are available. The CAD models are, I think, also available. It's relatively easy to build and easy to 3D print. So I included this because if you're building if you aim to build a custom quadruped for yourself, this is something you can absolutely build, and this would be also relatively cheaper. Now this robot is called Open Quadruped, and this is a pretty robust and interesting project, also not as actively maintained currently, but there's papers for this project. There's good documentation. If I click on the documentation now, we see here there's more details on the presentation, controllability, more technical details. There's videos there. There's details on electronics. So pretty interesting. Inverse kinematics and forward kinematics have been, of course, implemented here. There's details on the hardware, and there's 3D printing components here. There's STL and step files are available as well. So another interesting quadruped to look into.
不多说，先看效果。
So 30 robots so far, and this 30th robot is actually pretty interesting because it's a wheel-legged robot. So it is a legged robot, but it also has wheels. So this is a slightly different robot as compared to other robots. There's good documentation. It's called FOC Wheel-Legged Balance Robot Project. There's introduction videos. This is just it's showcasing it. Material costs. So this is in yen. You can convert it to dollars, but it would be also relatively cheaper to build. And the material costs are available here as I open.
Diode is usually two people in control. One person is usually holding the e-stop. So the e-stop is a switch that when you press it, it'll turn the robot off. So this is kind of a safety measure. And the second person is...
So this robot called Doggo, built by Stanford, is also pretty interesting, although this is also not being as actively maintained. If I open on the GitHub repository, I see that there's CAD files available. There's information about the software, but I don't think they use ROS in any case. There's more details on other GitHub repositories where the CAD files are available, and code. If I look at this code now, for instance, it is also not as actively developed. So this is something that you can take to get inspiration from for hardware and mechanism side of robotics, and that is something that is also absolutely fascinating. So there's also details on electronics and software. So if we look at the software, the Doggo software is relatively simple as far as things go. The gist is that we have a state machine that flips between different behaviors, and for each behavior we send different position commands and gains to 4 O drives. Okay, so they don't use any ROS, but they just directly control it, and they have these control repositories, and it's Arduino based as well, I think. So this is another interesting design of a quadruped called Metabot. Of course, this is something that you can take inspiration for your hardware system. and there's details on how to buy this kit. So the Metabot kit is also available here. It's designed for education and research and also for fun and hobbyists. There's details on mechanics, the mechanical parts of it, and then the electronics and things like that. Bill of materials is available, and it's also, I would say, on the cheaper end of robotics kits. Then there is dynamic robotic leg. So this is, I would say, if you want to explore the legged locomotion dynamics, walking gaits, all of these kinds of things, and you are mainly interested in researching those areas, then I think this is something to consider. So Open Leg is a really nice initiative. There's also Hackaday page for this. And as I go into, there's more videos and more details about the robot. All right, number 34. This is one of my favorite robots called Nibble by Petoycam, and this is a relatively small size robot, and it can be fun to play with, and it is absolutely open source. I love the documentation of this. It uses an OpenCat framework. It has ROS compatibility, and it is also not that expensive. So if I click on buy and build, it is on the cheaper end of robotics kits, $228, $229. So let's move on to the next robot now. So this one is another robot by Petoycam. So the previous one was a cat, and now this one is a dog. And again, I wouldn't go into details of it. It's basically the same links. Essentially, you can buy both the cat and the dog. Those are by Petoy links. These are really nice open source robots with very good documentation and actively being maintained. So another interesting robot is the one by Open Dynamic Robot Initiative, and this is to again explore the dynamics and kinematics and dynamics of robot. These have a lot of different repositories. Open Robot Actuator hardware is available. All of the different mechanics and electronics components are available here, which you can look into. There's step-by-step build instructions. There's also this web page, and there's more instructions on this. There's also access reference to research paper talking about this architecture that they are using for this. So an open torque control modular robot architecture for legged locomotion research. So they have talked about the kit and this robot in general. So this is a relatively recent quadruped robot called Dingo Quadruped, and it is being more actively maintained. So I am going to the GitHub repository now. You see it's more recent, and it has details on how the driver works. It has ROS noetic support, which is very good. This code is based on Stanford Pupper and NoteSpot databases. So NoteSpot is another robot that I actually haven't really covered in this list, but this is Also another open source robot that you can look into. So Stanford Pupper we've already seen in this video, or we would be seeing in the coming slides. The instructions on installation of it, although it is still based on Ubuntu 20.04, you might be working with Ubuntu 22.04. But yeah, absolutely something to consider. There's details on the CAD models that you can download from here.
It walks around fairly well. This is mostly walking in the same way that OpenDog version 2 works, however I now have higher torque joints using 10:1 cycloidal drives instead of 5:1 belt reductions. I left the project with the mechanics.
So this is a robot called OpenDog V3, and this has been developed by X Robots, and these have a really nice set of YouTube tutorials on how it works. Everything is explained in a lot of detail there. These you might have stumbled upon this channel by James Bruton, and these are absolutely amazing to watch. So this is the pupper robot that I already talked about a little bit. And this is a relatively more fragile quadruped, and it's Raspberry Pi based robot that can trot, walk, and jump. There's information on how it works. There's a separate project page which somehow doesn't seem to be available anymore. Stanford Student Robotics.org. Okay, so this is another interesting page, but this is something that you can look into. So this was the robot that we covered. And then there's documentation and build guide, which is what is important. And again, there's enough really good documentation on that. There's good community and good support. So we talked about wheeled mobile robots, we talked about legged robots. Now let's go on to manipulators and robot hands. This particular robot made in France is called Nereo robot, and it is also not as actively developed, but it is available for purchase. And this has a bill of materials also available, so you can really also assemble it yourself, or you can choose to buy it. So there's instructions on assembly, which I find really good here. And if you have to buy it, you can go on the website, and it's $4,000. So robotic manipulator arms are also quite expensive. Now, this is a very old robot, and it has been inspired from automatons. So, there was an automata that was actually uh, this robot arm base that was used to play chess in several hundreds of years ago. And this is basically inspired by that, but it is more modern. And it's still old. The components are really simple, so I think it is also on the cheaper side of robots. And there's also build instructions that you can find online, so that is why I have included it in the list of robots. As you see, it was last maintained 6 or 7 years ago. There's a website, and then uh, more details. There's some notebooks that are available, chess wise piece classification. So there's also some computer vision and machine learning that you can apply. So pretty interesting. Let's have a look at some other notebooks. So chess piece classification, chess piece error, and then there's arm error correction. So this would be also applying more machine learning and computer vision to this robot. It would be cheaper to build this hardware. Yes, this massive robot is called Thor, and this is also open source. You can actually build Thor by following the instructions on hackaday.io, and you can have a look at the CAD files on this in this repository, and I think this is something that you would find mostly beneficial if you are looking for some inspiration on hardware side of robotics. There's good documentation, but I don't think the software side of things is really as updated, so make sure to keep this in mind. If I open the bill of materials, I see all the individual components: servo motors, stepper motors, pulleys, nuts. So a lot of interesting mechanical components can be explored by means of working with this robot. So this robot is called Open Manipulator X, and this is also built by Robotics Git, and hence the documentation is very good. It's based on ROS. There is an e-manual for this, and the documentation is actually quite comprehensive. There's details about the hardware and its dimensions and all of these things, and you can really use the instructions to get to know the part list and what are the parts that are 3D printed, how can you assemble it. There's also videos showing that. This particular robot is called Small Robot Arm, and this is also open source. I like the overall design, it seems pretty robust, and this is also an older robot, so I wouldn't also rely on it for learning software, but you can build it and create your own software. There's instructions on how to assemble it on the in the repository itself, so there's a PDF that has all the details with nice illustrations.
机器臂都有的功能，所以并不算炫酷。这里值得一提的是开启视角功能的方法。大家可以注意到，整个机械臂的机身除了一个电源按钮之外是没有别的按键的。那么如何进
Another interesting robot is called Dummy Robot, and it has both GitHub repositories available, which are slightly actively updated, although all the instructions are in Chinese, and you can actually also get more details on this article by hackaday.com. Okay, so this relatively simple looking arm is called Evo arm, and you can really build it by following the instructions, hardware instructions on the GitHub repository itself, and there's more details on it. So it's Arduino based again, so software wise I don't think they use any ROS or any of the recent tools and systems, because it's also pretty old, 6 or 7 years old. Again, something to consider for manipulator hardware design. This wobbly looking robot is called Umi Robot. It It looks relatively simple, the overall design. It is slightly more active. The repository, it is based on Python, and you can really run it in a GUI and visualize things. And if you go on to this, you'd be able to see some of the images on components, and that might help you assemble it. I think the assembly process would be relatively simple for this. When it comes to documentation, I would not say that it has really strong documentation, but here is the link to it where it has certain videos on software. Actually, it is good enough documentation wise. There's also a paper, although it could be more formally organized, but there's CAD models available. There's details on software and things of that nature. This fancy looking robot by Poppy is called Poppy Ergo Junior, and it is relatively simple to assemble and build, and you can buy it on you can buy it for around 350 euros, and there is also good GitHub repository and support. Again, not the perfect thing for software, not based in ROS. In fact, they also use visual programming or some of the basic modes of programming, so might not be suitable if you are actually looking to work professionally as a robotic software engineer. But it has a nice utility. It's a fun little project that you can have for your home. You can build your own Poppy Ergo Junior as well. There's bill of materials available. There's details on suppliers available as well. I want to look at the software side of this as well. So if I go on the package, it's actually Python based, a lot of things. So it uses this package called PyBot. And so I think programming wise, it's still based in Python. So this is something that you can look into. Of course, I think there's no association with ROS for this robot, but that doesn't have to be a disadvantage necessarily. Also, there is not a lot of robot manipulator arms that are open source. There's more mobile robots, more wheeled robots in general that are available that are open source. So that is one thing. This dexterous open source robot by Headington Dynamics is actually called Dexter. And this is a pretty interesting robot because it can perform complex manipulation tasks. And it is also slightly more active. It has assembly instructions as other repositories. And if I go to firmware and core, okay, so there's build summaries, there's pictures of his bill of materials. I think this is again also something that is more suitable for hardware purposes, but of course you can use it for complex manipulation tasks as well. Let's have a look at the Dexter setup. So here I think this would give us more detail. So here there's instructions on assembly, connecting and boot up. So connect to Dexter. If I click on this repository, then there's more details on connection with it. So this is interesting. And then once you connect it, then there's boot up, and you communicate with the robot via DDE. So these are some things about this robot. I think it has a lot of components, so it might take more, it might cost you more to really build this. This is also more complex robot manipulator system to build. Number 50. So we have really talked about 49 robots before this. This giant robot is called Phase 4, and this robotic arm, it's cheaper than $1,000. Notice how they mention it is cheap, less than $1,000. Could also be pretty expensive for most of us. It uses 3D printed cycloidal gearboxes. All wires are hidden, giving it clean design. There's instructions on how to build it and everything. There's instructions on assembly. So this is also another open source robot manipulator arm that you can look into. Bill of materials is available. And there's an Excel sheet actually that they have provided with them. So screws, bearings, other 3D printed parts, all details are there. Total, it says $961, I think. So still expensive, but robot manipulator arms in general can also be more expensive. Now let's talk about some robot hands now. This is a pair of robot hands by Open Bionics, and there's a lot of build instructions, 46-page document that you can look into, contents about robot hand base, finger assembly, all the mechanical interesting components that are there. And if I look at the GitHub repository of this is by Open Bionics. And if I go to software, then they also have ROS support, so that is a good sign. It's Arduino based. There's instructions on how to control it using ROS topics. So that is good. This is actually good because it has ROS support and it can be used with Python. $52, almost getting to the end. So this is Robel, and in this video we see that it's trying to learn to perform a task from scratch, and you can really have a look at the platform on this page, and there's also details on the benchmark. You can use it with reinforcement learning. There's these um, hardware platforms that is used with the DKT and the claw. And if I go to the GitHub repository, it's by Google Research, but it's 4-year-old. And it talks about again the robot platforms, hardware, software. It uses Mojoko, which is interesting, but I think Mojoko now is more developed. It's based on the previous version of Mojoko. So if I go to Mojoko website here, so DeepMind has acquired Mojoko now, right? So Mojoko is being more actively developed. So there might need to, if you choose to use this repository and if you choose to work with this sort of a robot, then I think you might need to make some upgradation to the software because the software is outdated. Then comes one of my favorite open source robot hands called Dex Hand, and this is being actively developed, has really good ROS 2 support. and all of the instructions are there. Nothing much to say about it. It's really amazing. It's being actively developed. You've probably seen some of the videos um, of the creators really operating the hand. There's details on how to build it from scratch. It's really amazing that there's so many interesting open source robot projects that are available. Now, believe it or not, there's also open source humanoid robots that you can work with.
A plan can communicate with others in your place. A plan.
Glenn, this is a fun little humanoid robot. And if we go to the website, it's also, the software is also pretty old. There's assembly instructions here, printing details. Most of the components can be 3D printed here. There's tutorials on it. There's software installation instructions as well. So let's have a look at this. It actually works with ROS, which I was not aware of. So ROS installation deprecated. Okay, so yeah, you might have to look at it. I think it's the company is based in Japan. The company that builds this open source robot. But it's interesting because there would be it is compatible with ROS first of all, but unfortunately it's not as updated, and I think that is a major disadvantage of it. But it is one of the few open source robots available, humanoid robots that are available there.
Hello, my name is Andrew Wingate, and this is Evezer. It's an open source robotic arm that can help you fabricate and automate entire builds. And with a wide array of tool heads, it's basically a hackerspace unto itself.
Now, this is not a humanoid robot. I accidentally placed it in this category. This is actually a robot arm designed for manufacturing. It's an open source robotic manufacturing platform. This is another interesting robot which you probably wouldn't be building because it's built from cheap bits. Maybe it is something that you can look up to for inspiration if you're looking to build a cheap robotics kit, but it is pretty old. All of these components are pretty old here. If I look at the software documentation, uh, you can have a look at these software documentation and so on. Things are just slightly old, but what is interesting is that it also uses verbal communication, chatterbot based uh, operation of this robot. So this is absolutely something you can look into, and it's Raspberry Pi based. 57. So this is a robot by Poppy called Poppy Humanoid Robot. We had a look at one of Poppy's robot arm, open source robot arm, and this is a fully modular open source humanoid robot for research. I'm opening it and we see that it has instructions on how to build it. It has its bill of materials, and of course it is more expensive. It's a humanoid robot. It's $8,000 to $9,000. You have to install a Poppy board. There's a documentation that is available on how to do that. There's a documentation on how to program it. It's based on Linux, which is another positive. There's assembly guides. All the details are there. So also a very, very interesting project. One of the more cooler humanoid robots with lots of degrees of freedom. And interesting is that there's really good assembly instructions on that, and it's open source. So this is absolutely interesting. And if I go on to the GitHub repository, unfortunately, it's also not as actively maintained or being actively maintained, but it is one of the really more interesting humanoid robots that are available, and cool that it's open source. Now this robot is called OP3, and this is another of Robotics open source robots, also not actively maintained, but it has a good set of ROS packages. So I would be careful with buying this because of its inactivity and older versions of Ubuntu that they work with, unfortunately. But is a nice project. You can build this, you can use the instructions on how to assemble it and things like that. There's even good tutorials on this. If I go to hardware, there's data on assembly. You can take inspiration from for hardware again. For software, you might need some upgradation. 60 robots. So this is a really long video, and I can't believe that we have covered 60 robots already. This is a funny looking robot by Pollen Robotics called Ricci, and it's an open source interactive robot. It was being actively maintained 2 years ago, but this is Ricci 2019 repository that I've opened. There's also more recent versions of Ricci actually. So Ricci 2023, this is pretty good. It's based on ROS 2 Humble, so it is very actively maintained. So this is something that you should absolutely consider because it uses the latest frameworks here. In order to build it, you can go on the website and you can find more details on the hardware. You can actually buy it, but you have to contact them and then they would probably give you a code. So it's probably quite expensive. 61, almost going to the end. So this interesting little football playing robot is called Eros robot, and it has been used to participate in robotics soccer competitions. And this is the GitHub repository. It has talked about some of the specifications. If we go here, then there's ROS, these ROS packages and everything is there. So the compatibility wise and learning the right thing point of view, it's very good. And when I go to the official website, I see more details on it. And so you can find more details about this robot and how to build it, how to use it, how to program it. The GitHub repository is available as well. All right. So we have talked about a lot of robots now. What is left? What is left is quadrotors or drones. We have covered all the robots that can walk and slide or rotate, but we haven't covered any aerial robots so far. So let's talk about a few aerial robots, and these are the last set of robots that we will be considering for this video. Number 16. This robot is called Crazy Fly, and this is also open source. And if I go to the GitHub repository, it's by BitCraze, and it is actively being maintained. And there's good instructions on building and flashing it and contributing to it. And I'm sure they also have ROS support there. It's basically also using both C++ and Python. So let's just quickly have a look at the buying or building instructions, and you see there's this dependency list that is there. Operating system Ubuntu is there. It can work with the Windows, and a lot of things are mentioned here. So Crazy Fly, this is one of the drones, open source drones.
So with this build, now for that, we're going to need to connect the Pixar.
So there's these drones by PX4, or that use PX4 autopilot. This is the standard drone autopilot that is used for a lot of DJI drones and a lot of open source and even non-open source drones. So there's a PX4 user guide that if I click on this, there's a lot of really good documentation on assembling the peripherals, assembling airframes, and also software, sensors, all these kinds of things. So this is pretty well documented. It has assembly instructions for a lot of different components. So Holy Bro, Pixhawk 5X, wiring. So for Pixhawk, these are the instructions, and that moves us to the next robot, which is the last drone. The DJI Pixhawk. And this also uses the same software components and the same build instructions. So for open source, DJI robots are the most popular ones that are used. So that's a lot. This was a really long video where I talked about these open source robots that you can use to learn not just robotics software engineering, but also learn to build mechanical and electronics components. Although the primary focus should be on robotics software engineering, that has been the main target of this video. So hopefully this was helpful, and I wish you all the best on your journey to become a self-taught robotics software engineer.